Okay, we're going to start our journey by learning about classes. In this lecture, I'm going to introduce you to the basics of classes. I'm going to show you a real-world example of classes and why we need them. Then I'm going to talk about what is an object and how it's different from a class. And finally, we'll talk about static members. So what is a class? A class is simply a building block of a software application. So in the real world, an application consists of multiple classes, each responsible for a particular behavior in the application. And overall, all these classes together will provide the behavior expected from the application. Let's take a look at a real-world example. We all are familiar with the concept of blogs and posts. Let's say we would like to implement a web application as a blog engine. With a typical layered architecture, our software application consists of at least 3 layers: presentation, business logic, which is also referred to as domain layer, and data access, which is also referred to as persistence layer. In each of these layers, we can have classes, each responsible for something particular. For example, in the presentation layer, we can have a class like PostView, which is purely responsible for displaying a post to the user. In the business logic or domain layer, we can have the concept of post itself. And finally, in the data access or persistence layer, we can have a class like PostRepository, which knows how to save a post to the database or load it from a database. A real-world application often consists of hundreds or even thousands of classes collaborating with each other. So for you as a C# programmer, it's absolutely crucial to understand classes and how to use them effectively to build a maintainable, clean, robust, reliable application. This lecture is pretty basic, but as we progress in this course, in every lecture and in every section, I teach you something new about classes. By the end of this course, you're going to learn a lot of materials about how to use classes and interfaces to build loosely coupled, extensible, and maintainable applications. So let's continue our journey. Now we know a little bit about a class. So it's a type that we developers define and give it a responsibility depending on the kind of application we're building and the layer that class belongs to. But what is inside a class? A class essentially has 2 parts: data, which is represented by fields, and behavior, which is represented by methods or functions. Here is how we illustrate a class in UML or Unified Modeling Language. UML is a graphical language for representing classes and their collaboration. And we use that as a communication tool as part of building software. So in UML, a class has 3 parts. The first part is the name of the class. Then here are the fields or attributes of that class, which represent data about that class. And finally, we've got the methods or functions, which provide some behavior. So in this example, our person class has fields like name, age, height, and weight, and it has methods like walk, talk, eat, and sleep. Let's take a look at another example. We talked about blogs and posts. So a blog post can have attributes or fields like title, description, and date time. And it can have methods like publish, like, or comment, which receives a message. A term that is often used with classes and sometimes used interchangeably is an object. But an object is fundamentally different from a class, yet a lot of developers, including myself, sometimes use the word object to refer to a class. But an object is essentially an instance of a class that resides in the memory. So back to our person example, if person is a class, we can have objects like John, Mary, and Scott. These are instances of that person. The person class or the person type defines the blueprint from which we can create objects. At runtime, these objects in the memory talk to each other, and as a result, we get the behavior expected from the application. Now let's see how we can declare a class in C#. Here's a basic syntax for declaring a class. Public and class are keywords, are reserved keywords in C#, and that's why I've indicated them with blue. Public is what we call an access modifier, and that's something you're going to learn later in this section. So for now, don't worry about it. Each class should have a name or an identifier, like person. In terms of naming convention, in C# we use Pascal case to name our classes. What is Pascal case? In Pascal case, the first letter of every word should be uppercase. We also have camel case, in which the first letter of the first word should be lowercase, but the first letter of every word after that should be uppercase. In C#, we use camel case when naming parameters of methods, as you will see later in the section. So back to the declaration of our class. The class can have fields and methods, which we refer to as members of that class. We put members inside these curly braces here. We can declare a field for this class and call it name. Similar to the class, we start with an access modifier, in this case public, then the data type for that field, and an identifier. In the real-world applications, we shouldn't declare fields with public. This is purely for taking you on a step-by-step journey without confusing you with a lot of details along the way. As we progress in this section, you will find the best way to declare fields. Okay, now let's see how we can declare a method in this class. Very similar. So we start with an access modifier, and here is the signature of the method. So a method can have a return type. In this case, void means it doesn't return any value. Then it has an identifier, and here in brackets we can put any parameters that that method may need. Inside that method, we have the code. And here we can access any of the members of that class. So in this example, I'm simply using console.writeLine to display the name of that person on the console. Okay, now that we have a class, let's see how we can create an object or an instance from it. To do that, we use the new operator. So we start with the type of the class, in this case person, we give it an identifier, and then we use the new operator along with the name of the class to initialize an instance of that class. Note that here we are using camel notation for naming the person object. A shorter way to write this code is to use var. Var is a C# keyword. And the reason we use that is to save us from typing the full name of a class, because sometimes the name of the class might be quite a few characters. Plus, as you see, it's a little bit of duplication to repeat the name of the class in two places. So we use the var keyword, and the compiler automatically knows that this person object is of type person. Now that we have an object, we can access members of that object, like accessing the name field and giving it a value. Or we can call one of its methods. Before we start coding, let's talk about class members. In C#, we have two types of class members. We have instance members and static members. An instance member is accessible from an object. You have already seen that before. So we create a person object and then call the introduce method on the object. But we also have static members, and a static member is accessible from the class, not an object. An example of that is console.writeLine. So console is a class and writeLine is a static method. So we don't have to create an instance of console using the new operator in order to call writeLine. Now you may wonder, why do we use static members? Basically, we use them to represent concepts that are singleton. That means we should have only one instance of that concept in the memory. Think of the concept of the current date time. We should have only one place in the memory where we know the current date time. It doesn't make sense to have different objects, each telling us that current date time is a different value. Another example is console.writeLine. When we run a console application, basically we have only one console, and that's why the console class and all its members are defined as static. To declare a member as static, all you have to do is to use the static keyword after the access modifier. You can use static on any members of a class. Okay, that's enough theory. Let's open up Visual Studio and do some coding. Okay, here I've got a console application in Visual Studio. And that's where we're going to do all the coding for this course. We're not going to get into the complexity of Windows applications or web applications or mobile apps. We just want to learn about classes, interfaces, and object-oriented programming. What you learn here, you can always apply in any kind of application you're going to build. Okay, now let's start creating our first class. So we create a class by public class. Let's give it a name like person. Let's define a field for it. So public string name. Again, for now, we're going to use public until we get to the lecture about access modifiers. And then we're going to learn a better way to define fields. And let's create a method called introduce. I want this method to take a parameter, and that's the name of the other person that this person is going to introduce himself to. So let's say introduce to, and here we use the console class, the WriteLine method. Hi, 0, I am 1. Basically, what we have here is what we call a format string. So it's like a template. And here are parameters that we will fill by some values. So I want the first parameter to be filled by the value of to argument. And the second one is going to be the name field stored in the class. Now that we have this class, let's create an object from it. So we go to the main method. We can either go person equals new person, or a shorter way is to use var. So with var, we'll let the compiler figure out what is the type of this person object. Well, compiler knows it's assigned to a new person object here. So when you hover your mouse over var, you see the tooltip says person. Now we can assign this person name. That name equals, say, John. And then we can call the introduce method and pass another name as an argument. Say, introduce yourself to Mosh. Now, if you run this application, you see, hi Mosh, I'm John. Now let's take this to the next level. Let's say we would like to create a person object from a string. What we can do is to create a parse method. So let's go and define a parse method here. The parse method should take a string and return a person object. So person parse string some str. Basically, what we need to do here is to create a person object, set the name field based on the str argument here, and then return that. So var person equals new person. We set the name to str, and finally return that person. Now, the interesting thing here is, if you want to use this parse method, we have to use it on an object because it's an instance method. So that means I can go here and say person.parse and give it a name like John, and that returns a person object. So let's call it P. And we can get rid of this name here for now. See, it's a little bit weird. We have to create a person object first and then call the parse method to return a person object. It just doesn't make sense. That's where we use a static modifier. So we can declare this parse method as a static. And this way, we don't have to create a person object first in order to parse a string. So we can simply change this code to use the person class. We parse that string, and now we have a person object. And finally, we can call the introduce method on it. Let's run the application. We get the same result. So that's a use case for using a static member. A static member is only accessible from the class and not an object. That's pretty much it for this lecture. In the next lecture, we're going to learn about constructors. I hope you enjoyed this lecture, and thank you for watching.